We are getting breaking developments at this hour from observatories around the globe, focused on an event currently unfolding deep within our own solar system. The subject of this intense scrutiny is an interstellar object, a visitor from another star system, designated 3I Atlas. And what we are seeing in the very latest, highest resolution images is forcing the entire astronomical community to pause, to re-evaluate fundamental principles of celestial mechanics, and to confront a puzzle that is as profound as it is unexpected. Let me be absolutely clear from the outset. This object poses absolutely no threat to our planet. This is not a situation of impending danger, nor is it the stuff of science fiction. It is, however, a developing scientific story of the highest order, a genuine mystery playing out in real time, because 3I Atlas is not behaving like any normal comet we have ever encountered. Just into our science desk are new images, processed within the last 72 hours, and they are arriving just days before this object makes its closest approach to Earth on December 19th. These images reveal with stunning clarity a massive structure pointing directly toward our Sun. This feature, known to astronomers as an anti-tail, is not just a minor anomaly. The data coming in confirms that the anti-tail of 3I Atlas is larger, brighter, and more persistent than anything ever before observed on an object that has journeyed to us from another star. To understand the sheer magnitude of this anomaly, we have to first understand a basic foundational rule of astronomy, a rule that is taught in every introductory course and has been observed for centuries. Comets are, in one key way, very simple and predictable. They are often called dirty snowballs, collections of ice, dust, and rock. As a comet travels from the outer solar system and gets closer to the Sun, it begins to heat up. The Sun's intense radiation and the solar wind, a constant stream of charged particles flowing out from the Sun, act like a powerful cosmic blow-dryer. This energy vaporizes the ices on the comet's surface and pushes the resulting gas and loosened dust particles away from the nucleus. This process creates the beautiful ethereal tail that we associate with comets. And because the force, the solar wind and radiation pressure, is always coming from the Sun, the tail always points away from the Sun. It acts like a weather vane in a constant wind, or a flag permanently blowing away from the flagpole. This behavior is so consistent, so reliable, that it is considered a fundamental law of cometary physics. But the data on 3I Atlas shows that this object is breaking that rule in the most spectacular fashion imaginable. Instead of a tail pointing away from the Sun, its most prominent feature is a vast glowing structure that stretches directly back toward the Sun. It is defying the constant push of solar radiation. It is, in effect, flying its flag directly into the wind, and this is a physical contradiction that has scientists around the world scrambling for an explanation. The scale of this anti-tail is almost beyond comprehension. We are not talking about a small faint wisp. The latest processed images, which have been carefully calibrated to measure its true extent, show this structure now stretches for hundreds of thousands of kilometers out from the object's nucleus. In the most recent and detailed analysis, this sunward-pointing feature is estimated to reach a length of nearly 500,000 kilometers. Let's put that number into a perspective we can all understand. The average distance from our planet, Earth, to our own moon is approximately 384,400 kilometers. This means the anti-tail of 3I Atlas is longer than the distance from the Earth to the moon. Imagine standing on Earth, looking up at the moon, and trying to visualize a structure of dust and gas that could span that entire gap and extend even further into the void. That is the sheer mind-boggling scale of the phenomenon we are currently witnessing. An unusual structure of this size would be an exceptional discovery under any circumstances. But what elevates this from a simple curiosity to a profound scientific puzzle is the timing of this observation. The moment at which we are seeing this is what makes it so deeply perplexing. 3I Atlas has already passed its closest point to the Sun, an event astronomers call perihelion. That was its moment of maximum heating, its trial by fire. That event occurred weeks ago. According to every model of cometary behavior we have, what should be happening right now is a gradual cool down. The solar heating should be decreasing as the object moves farther away from the Sun on its outbound journey. Consequently, all of its cometary activity, the outgassing, the dust release, should be slowing down significantly. It should be becoming less active, not more. Any unusual features, especially delicate structures like a sunward-facing dust tail that has to fight against solar pressure, should be the first things to weaken to dissipate and to disappear altogether. It's like a pot of water taken off a hot stove. The boiling should be subsiding. Instead, we are observing the exact opposite. The anti-tail of 3i Atlas remains sharply defined. It is not fading away into a diffuse cloud. It is a persistent, well-structured and incredibly bright feature that has maintained its integrity for weeks after it should have begun to decay. This observation directly contradicts our expectations and suggests that a powerful ongoing process is at work, a process that is actively maintaining and possibly even feeding this structure against all known physical forces that should be destroying it. To get a better look, astronomers analysing this newest flood of data have applied some of the most advanced image processing techniques available. They are using powerful computational tools, including a specific method involving rotational gradient filters to digitally subtract the overwhelming glare from the comet's central core, or coma. This technique is like using a highly sophisticated filter to remove city lights from a photograph of the night sky, allowing the faint, delicate light of distant stars and nebula to become visible. In this case, it allows scientists to isolate and enhance the incredibly faint structures and patterns of motion hidden within the anti-tail's glow. And what they have found is revolutionary. This is not a simple uniform blur of dust. The processed images reveal that the anti-tail possesses a remarkable degree of internal definition. There are subtle layers visible within the structure, almost like the rings of a tree. There are clear variations in brightness along its length, indicating regions of higher and lower dust density. Most importantly, it shows a clear and unambiguous directional structure. This is not a random cloud of material that happens to be in a particular place. The evidence strongly suggests that the material composing this enormous tail is not just drifting randomly in space. It is moving in a highly organized, almost coherent way to achieve and maintain its current, colossal size over the observed period. The physics required to make this happen are staggering. For this structure to exist, the dust particles within the anti-tail must be actively traveling toward the Sun at incredibly high speeds, relative to the nucleus of 3i Atlas. The initial calculations, based on the structure's length and the time it has persisted, suggest these speeds must exceed 100 meters per second. To put that into perspective, that is over 360 kilometers per hour, or more than 20 miles per hour. This material is being actively ejected or fired from the nucleus with enough force to overcome the constant outward push of the Sun's radiation and travel upstream against the solar wind. To sustain that kind of motion with that kind of velocity for more than a month after the object has passed its point of maximum solar heating is something that is extremely difficult, if not impossible, to explain using our standard, accepted models of how comets work. Naturally, the scientific community is racing to propose explanations that could account for this bizarre behaviour. Several hypotheses are currently being debated, though each comes with its own set of significant challenges. One leading possibility is a phenomenon known as uneven outgassing. This theory suggests that the volatile materials, the ices that turn into gas, are not evenly distributed across the surface of 3i Atlas. Instead, they might be buried in pockets beneath a crust of dark insulating material. As the object rotates, different parts of its surface are exposed to sunlight. If a particularly rich deposit of volatile ice is located on the side that faces the Sun during its rotation, it could heat up rapidly and erupt in a powerful focused jet of gas and dust. If this jet is strong enough, it could theoretically push very fine dust particles inward, creating a stream of material that flows against the gentle but persistent pressure from the Sun. This would be like a small, powerful rocket engine on one side of the object, firing a plume of exhaust directly toward the Sun. Another possibility being explored involves the complex and delicate dynamics of very specific types of dust grains. This model proposes that extremely small, almost microscopic dust particles are being shaped by a very sensitive and intricate balance of forces. These forces include the object's own weak gravity, the much stronger gravitational pull of the Sun, the outward push of solar radiation pressure, and critically, the specific viewing geometry from our perspective here on Earth. Under just the right conditions, this interplay of forces could theoretically trap or organize dust into a structure that appears to be a stable sunward-pointing tail from our line of sight, even as the individual dust particles within it are slowly evolving and moving along complex orbital paths. It would be a kind of optical illusion created by physics, a structure that seems solid and persistent, but is actually a fleeting alignment of moving particles. But here's the critical problem. Even these advanced and complex explanations are struggling to fully match the raw data we are seeing in the images. The anti-tail of 3I Atlas is not the kind of feature these models would predict. It is not faint, it is remarkably bright. It is not short-lived. It has persisted for weeks with little sign of weakening. And it is certainly not subtle. It is a gigantic, well-defined structure that dominates the object's appearance. The existing theories tend to produce features that are much smaller and more transient. Trying to use them to explain the sheer scale and longevity of what we are witnessing with 3I Atlas is like trying to explain a hurricane using a model designed for a gentle breeze. The energy and the scale just don't match up. This brings us to the present moment and the immense significance of the upcoming Earth flyby. A focused global observation campaign is already well underway. As Earth moves in its orbit, it is approaching its closest alignment with 3I Atlas, which will occur on December 19th. At this very moment, telescopes on every continent, both professional and amateur, are being locked onto this enigmatic object, gathering as much data as possible during this critical window. The flyby itself will occur at a safe distance of roughly 29 million kilometers. That is a vast distance, more than 1.5 times the distance from the Earth to the Sun, so there is no cause for alarm. But in astronomical terms, this is a golden opportunity. This event offers the best, and likely the last, observational opportunity that humanity will ever have to study this unique interstellar visitor in such detail. And the fact that it is an interstellar visitor is what makes this entire event so profoundly important. 3I Atlas is not from here. It is not a native member of our solar system. It did not form from the same cloud of gas and dust that created our Sun, our Earth, and all the other planets and comets we are familiar with. This object formed in a completely different planetary system, orbiting another star, countless light years away. It was born under physical and chemical conditions that we can only model indirectly through our telescopes. After its formation, it was likely ejected from its home system and began an immense journey. It has travelled through the vast, cold and empty expanse of interstellar space for millions, perhaps even billions, of years before its trajectory happened, to bring it briefly through our own cosmic neighbourhood. We have only just begun to realise that such objects exist. In the entirety of human history, we have only positively identified a handful of these interstellar travellers. Each one represents a priceless scientific artefact, a physical sample from another solar system delivered directly to our doorstep. Each one challenges our assumptions about how planetary systems form and evolve. Each one expands the boundary of what we consider to be normal behaviour for small bodies in space because they show us what is possible under a different set of rules. We all remember the first confirmed interstellar visitor, the object named Oumuamua, which passed through our system in 2017. It was a tantalising but frustrating encounter. Oumuamua was too small, too faint, and moving far too fast for us to get a truly good look. It was a brief, blurry glimpse of something extraordinary, and it left us with more questions than answers, including intense debate led by figures like astrophysicist Avi Loeb about its potentially artificial origins. But 3I Atlas is different. This is the opportunity we have been waiting for. It is significantly brighter than Oumuamua. It is making a closer approach to Earth, giving our telescopes a better vantage point. And most importantly, its structure is far more active and revealing, displaying features like this enormous anti-tail that give us tangible physical clues to analyse. The newest, most detailed imagery is providing even more layers to this mystery. The data shows clear evidence of asymmetrical activity. The anti-tail does not fan out evenly from the nucleus in a perfect cone. Instead, it appears shaped, guided, and influenced by forces we are still struggling to understand. It has a defined shape, suggesting the process creating it is not random, but directed. Some of the processed image frames even hint at fine separations or filaments within the structure. The current interpretation is that this is not evidence of the object breaking apart or fragmenting. Instead, it is likely evidence of layered motion within the anti-tail. This implies that different types of materials, perhaps larger, heavier dust grains versus smaller, lighter ones or particles with different compositions, are responding differently to the complex forces at play. It's as if we are seeing different currents within a single massive river of dust, each flowing at a slightly different speed or in a slightly different direction, all while moving towards the Sun. It is essential once again to emphasize that there is absolutely no indication of any danger to our planet. The orbit of 3I Atlas is stable and has been calculated with a very high degree of precision. Its trajectory is well understood by tracking stations around the world. It will not collide with Earth, and it poses zero risk to our planet or our civilization. The true significance of this moment is not rooted in fear, but in the thrill of pure discovery. This is a moment for wonder, for curiosity, and for the relentless pursuit of knowledge. As that critical date of December 19th approaches, the scientific investigation is intensifying by the hour. Astronomers are not just taking pictures, they are collecting a continuous stream of comprehensive data. They are making precise brightness measurements to determine how much material the object is shedding over time. They are gathering thermal profiles to understand the temperature of its surface and what that might tell us about its composition. They are monitoring its rotational behavior, trying to determine how fast it is spinning and if that spin is changing. And of course they are documenting the structural evolution of the anti-tail, watching for any changes in its shape, size or brightness that could provide the key to unlocking this mystery. With every new piece of data, with every new analysis, the picture that is emerging becomes a little bit clearer, and what it shows is an object that defies easy categorization. 3I Atlas is not behaving like a typical comet from our own solar system. It is not behaving like a typical asteroid. It is not like anything we have a complete and ready explanation for. Its defining anomalous characteristics are now beyond dispute. Its primary tail, its anti-tail, remains stubbornly pointed toward the Sun, in defiance of known physics. Its scale remains extreme, dwarfing any similar features we have ever seen. And its persistence, its refusal to fade away after passing the Sun, continues to defy all of our simple explanations. We must also recognize that this unique observational window is rapidly closing. As 3I Atlas continues on its path, it will soon move farther and farther away from both the Sun and the Earth. Its brightness will fade, and the incredible details we are able to capture now will soon become impossible to see, even with our most powerful telescopes. The images, the spectra, and the measurements we are capturing right now will become the definitive data points on this object, a precious archive that will be studied by scientists for decades, perhaps even centuries to come. This is our final close look at a genuine interstellar relic as it passes suddenly and majestically through our home system. This object is not delivering a message in a language we can understand. It is not announcing its presence with a fanfare. It is revealing its extraordinary story in the universal language of the cosmos. Through physics, through motion, and through light. It is telling us about the star system it came from, about the forces that shaped it, and about its long, solitary voyage through the galaxy. And for this one brief fleeting moment in December, all of humanity, through the eyes of its astronomers, is watching, listening, and learning. The data is still pouring in, and the story of 3I Atlas is far from over. We will continue to bring you updates as this unprecedented astronomical event unfolds, and we are getting further analysis, this time focusing on the composition of the material within this incredible structure. Spectroscopic data, which breaks down the light from the anti-tail into its constituent chemical fingerprints, is starting to provide the first clues as to what 3I Atlas is actually made of. The initial readings are suggesting a composition that is both familiar and strangely alien. While the expected signatures of water ice and common silicates are present, the ratios appear to be anomalous. Specifically, the spectral lines associated with certain carbon-based compounds, possibly complex organic molecules, are far stronger than what we typically see in comets originating from our own Oort cloud or Kuiper belt. This potential discovery of an unusual chemical makeup could be the key to the immense energy problem that has baffled physicists for the past few weeks. The standard sublimation of water ice, the process that drives activity in our solar system's comets, simply cannot generate the sustained, focused thrust needed to create and maintain a structure of this magnitude against the Sun's constant pressure. It doesn't provide enough horsepower, but if these potentially exotic organic compounds are far more volatile, or if they react to solar radiation in a more energetic, explosive way, it could provide the missing piece of the physical puzzle. We could be looking at a kind of chemical engine far more efficient and powerful than anything native to our system, a testament to a different planetary nursery with a different set of ingredients. This leads to another theory that is gaining traction in the last 12 hours, one that centers on a possible catastrophic event. Some researchers are now proposing that 3I Atlas may have undergone a recent partial fragmentation, perhaps as it endured the immense thermal and gravitational stresses of its perihelion passage. This wouldn't be a complete breakup, but rather a massive carving event, akin to a polar ice shelf shedding an iceberg the size of a small country. Such an event would have exposed a vast, pristine surface of highly volatile material from the object's deep interior, material that has been shielded from the harsh radiation of interstellar space for millions of years. This sudden, violent exposure would be like uncorking a cosmic champagne bottle, releasing a sustained high-pressure blast of gas and dust that could easily power the anti-tail for weeks, or even months after the initial event. Observatories are now frantically reanalyzing their data, looking for any sudden brightening in the object's light curve weeks ago that might correspond to such a fracture, or for any evidence of a secondary nucleus trailing the main body. Whether the final answer lies in its exotic chemistry or in a dramatic physical breakup, the implications remain staggering. 3I Atlas is providing us with a direct measurement of the raw materials available for building planets around another star. If its composition is indeed proven to be rich in complex organics, it significantly strengthens the hypothesis that the fundamental building blocks for life may be common throughout the galaxy, actively transported between star systems by natural messengers just like this one. Every photon of light collected from this object, every data point logged, is another word in a chapter of galactic history that humanity is now reading for the very first time. The ongoing analysis is a race against time before this visitor recedes back into the darkness, its secrets intact.